So in today's webinar, what we will see is I'll give you a short introduction to MapleMBSE. So if this is your first time looking at our webinar, I'll give you a short introduction to what MapleMBSE is, what is the advantage when you use it with your MBSE process. Then we will go into seeing how MapleMBSE is able to achieve the transformation from the model to the tables that we are going to see. So this transformation language, we call it as QPE, query path expression. This is something that's for MapleMBSE. Then I'll show you how to create a configuration file. What we will use is we'll use a functional decomposition template. We'll just create a very simple template to query some functions from a Capella model. We will see how we can refine the functions, like from a higher level function to a lower level function, and that's what today's webinar will be. So what MapleMBSE can help you achieve is it can help you to accelerate the introduction of MBSE in your organization. So the reason behind this is like the user who's going to interact through MapleMBSE, they don't need to understand the MBSE process or what the Arcadia model or the modeling terminologies from your Capella. So they would be interfacing with a very simple Excel view using which you can get information from the model view, review the information, you can edit the information and save it back to the Capella model. So since the interface is simple and it can bring in like different stakeholders across disciplines, because they don't need to understand like the modeling terminologies. So this makes it easy for them to communicate, to capture knowledge using a familiar interfaces. This eventually gives us like the benefit to reduce the project risk and cost, because the stakeholders are now interacting with a view that is familiar to them, and they're also interacting through a centralized model. They always have the updated information that they can use to review or to capture their knowledge of the system model. So what MapleMBSE actually is, it is a bidirectional connection to your system model. You can get the model information, the latest model information through different views that you can generate using MapleMBSE. And all these views, we are going to see how to customize the views, and the user can create their own view based on like the modeling domains that you have extended using different profiles from Capella. For example, if you're using the requirements view add-on or the viewpoints that's available from the Capella viewpoints, we will be able to incorporate those also into creating the configurations that will query your Capella model. So in addition to Capella, we also have interfaces to other modeling tools like Magic Draw or Cameo through Teamwork Cloud, Rhapsody, and so on. And some of the typical use cases that we actually involve in, or like say you can create the views for interface control. For example, let's say on the physical architecture level, you can get the physical components. What are the different interface for the physical component? How these interfaces or the ports of your physical component can connect. And you can also create views like safety analysis. Like if you want to perform a safety analysis over the different architecture levels, like on the logical or the physical, either on the physical component or on the physical functions, you will be able to create these views, use the PVMD profile to extend the domain and perform safety analysis. So these are, again, like these are some of the common use cases that you will see with MapleMBSE, like functional decomposition. You can integrate list of components, define the hierarchy, and save it back to your Capella model, and so on. And another common thing that you can also do with MapleMBSE is you can create the traceability matrix between, let's say, if you want to view if all your system functions have been related to the logical function, or if the logical functions come from certain requirements, we can see if all the requirements have been met in a matrix that we can generate from MapleMBSE and so on. So for The transformation language itself, MapleMBSE uses a tree-based transformation language. So what it basically does is it queries the model, it generates the elements based on how it's being contained by a top-level element. Like example, if the physical functions are in the physical functions package, then the physical function can own another sub-physical function and so on. MapleMBSE will capture this information and generate tables based on it. And this transformation is done actually by the query path expression. We call this as QPE. The query itself, it's very similar to how you will create queries using XPath to query the models. So it's very similar to that. But the terms that we will be using in the query language will be based on the Capella E code itself. So for example, if it's physical function, we will be using physical function in our query. If it's if it is being contained in a physical function package, we will be using that same terminology in the queries also. When you create your own query path expression or the queries to your Capella model, you'll be interacting with three different types of information that's in the Capella model. So the first one would be the classifiers. So classifiers are nothing but they are the type of element that you want to show in your Excel view. For examples for classifiers could be the, let's say, the operational activity, physical function, logical function, or physical component, logical component, etc. So these are the classifiers. So classifiers are the type of elements that we want to interact using the Capella, from the Capella in our Excel view. And the attributes, they are nothing but they are the properties of the classifier. So for example, the physical function as a name, so that is an attribute. And let's say if there is a package which has a visibility, so that is an attribute. Or the physical component as a kind, let's say if it's a behavior or a node, so this is an attribute. So anything that defines the classifier, they are the attributes. And finally, we also have references. So references are nothing but they are just pointers to a different model element. For example, let's say a functional exchange. A functional exchange does not own the source function or the target function. So the functional exchange just as a pointer that connects to a source and the target. So these are what are references that we will interact with. And it's combination of these three information that will be generating a configuration file. So that's what we'll use in MapleMBSE to generate the different views. So it's just the combination of these three information we will use to create a configuration file in MapleMBSE. So to give you an example of how the queries work, let's say, for example, we want to work with the operation activity. So we would define a data source. So we'll get to the details of data source and what it is in the later slides. But let's say the way the query works is you will start from the root model. So that's, for example, it would be your Capella project that you have created. So you will start from the root and then you will navigate to the operational activity. So for example, if I want to get information about the operational architecture, so from the root model, I'll navigate to the system engineering element or which is by the own model routes. And then I'll navigate to the different architecture the system engineering element owns, and I'll filter it based on the operational analysis. So for example, if I want to get to a logical architecture, so instead of operational analysis, I'll say that within the own architecture, I want to get information of the logical architecture and so on. And we can break the queries or we can change them together. So to get, let's say, the operation activity from the operational analysis package, I'm finding the operational activity and package. From the operational activity package, I'm finding the root operational activity. From the root operational activity, we navigate to the different own functions that are of the type operational activity. So this is how we navigate. Again, this navigation would be similar to how your Capella model is structured. The main advantage that you have with Capella is that once you create a configuration file and this navigations, you can use it across the different projects. So once you create it for a specific project, given the Arcadia methodology is the same, and the way the project or contained or structured is the same, we'll be able to reuse the configuration files to different projects that we want. And the type of element or the classifier that I mentioned, we put them between square bracket, and this is just called as a qualifier. So qualifier, you can see that we can mention the type of element we want to bring into the Excel view. And you can also add a filter saying, okay, from the different functions, I specifically want to work with the root operational activity or the root system function or the logical function and so on. So the qualifier is nothing but it combines the type of element that you want to work with a filter. So that's what a qualifier is. So we saw what the QPE is or how we build the QPE. The terms that we are using in the QPE, for example, the own model routes or the system engineering, operational analysis, all these are terms that come from the Capella eCore itself. So the Capella eCore has defined that the model should be structured in this way. This is how the root operation activity should be called. This is how the package should be called, and so on. So we are just incorporating what terms are being defined in the Capella eCore or in the Capella model architecture in our queries too. So based on the queries that we have seen, we build the configuration file. So configuration file, it is nothing but it has queries that will map information from our Capella model to the views that we are going to see in Excel, like as tables or matrices and so on. So the configuration file will have 5 modules. The first module is the eCore import. So this is basically nothing but a way of saying to MapleMBSE that we are going to work with the Capella model, or we are going to work with a different tool like a SysML model or so on. So eCore import is nothing but we will say these are the eCores, or this is the type of model that we are going to work with. And for Capella, it's going to remain the same across different projects. So every time there is an eCore change, that again, this is based on when there is a new Capella version, like from 1.4 to 5, or if you move from 5 to 6, the eCore also updates. But as long as you are within the same Capella version, the eCore import or this section of the config file is going to be the same across all your. The module workbook and the worksheet template. So these two modules gives you control over how you want the views to be in your Excel interface. Like you can say, this is how I want the worksheet to be called from. Like this is how I want the worksheet to be named. This is where I want the table to display. The view of the table, like if you want it to be a vertical table or an horizontal or like a matrix view. So this information goes into the worksheet template. In addition to that, you can also control the arrangement of the column. Like I want to display, for example, let's say, let's take the example of the functional decomposition we'll be seeing today. So I'll say display level 1 function in one column, level 2 function in the second column, level 3 function in the third column, description probably in the last column, and so on. So this arrangement is also controlled by the worksheet template. So the data source and the sync table schema is where you will be using the QPEs or the query path expression for us to navigate through the Capella model and also to get the information that we want to expose to the user. So we already saw on the previous slide like how a data source is. A data source is nothing but a navigation to the part of the model that we want to work with. So if I want to work with logical function, I will navigate to the logical architecture. Within the logical architecture, I will navigate to where my logical functions are. And then we will use the schema to mention what information from the logical function we require. So for example, let's say for the logical function, I want to get name of the logical function and also description. and I want to display this information in the Excel view. So that information goes into the sync table schema. So data source is nothing but a pointer to the part of the Capella model that we want to work with. Sync table schema is where we will say, okay, for this function, I want this information. Then navigate to, like, let's say another subfunction. So for the level 2 subfunction, give me again the name and description and so on. So this information goes into the sync table schema. So once we create these 5 modules, we'll be able to see when you launch the config file and connect to Capella model, you will be able to see the information being captured, and it will work bidirectionally that any updated information from Capella can be seen in the Excel view. And same way, if a user modifies the Excel view and save the changes back to the Capella model, you'll be able to see this as Capella elements itself. Okay. And in order to make creating the queries or the configuration file easier, we have a plugin for a MapleMBSE editor. So this plugin is something that goes into your Capella installation. So the advantage of using the editor is, like, as I mentioned to you in the previous slide, the config file, they are just basically queries to your Capella model. So the configuration file, you can use any text editor to edit or create the queries. But when you use the MapleMBSE editor, the advantage is that you will get syntax highlighting and syntax checking. We update the editor every release. Like with every release, we extend the querying capability with our own features, and you'll be able to get those new features in every release also. The editor will also give you some suggestions for the queries that are relevant to the query that you're building up. For example, let's say if you're building up a query on the physical level, it will suggest you the possible queries relevant to that component or the function that you are querying. And you can also import the Capella eCore into the editor, and you can actually navigate through the eCore to see what are all the possible queries in addition to the suggestions that is being generated by the editor. You can see. And to edit the MSC file or to install the MapleMBSE editor, from your Capella installation, you can go to Help, Install New Software, and select the MapleMBSE editor. And the editor is available on our website to download. And once you install the editor, we can create a new file. Again, when we work on the functional decomposition demo, I'm going to show you how this works. But this is how you install. Like you go to Help, Install New Software, and select the MapleMBSE editor, and you follow the on-script instructions. So I have given you a brief of what the configuration file is, how the query works, how to create the queries, and so on. So what we will do now is I have already actually installed my MapleMBSE editor plugin in Capella. So I'm going to use that. We will create a new file, and once we create that file that queries logical functions, let's say up to level 3. So we are going to create a configuration file up to level 3 for logical functions, like 3 levels of subfunctions. We will launch the config file, connect to a model that I have created in Capella, and we will see how the information is being displayed in the template. And for the example, what we will consider is I have created a fitness tracker model, and with some functions that is already defined at different architecture level. So here I have defined the fitness tracker, and I have defined in the operational analysis level, like what are the different operational activity the fitness tracker can have. Then I have defined the OAB entity diagram and capture what are the different entities or the actors and their operational activities that is being allocated to them. And we also have the system analysis or the system architecture level, where I have captured the activity tracker, what are the function it does, same way what are the other actors and their function and their functional exchange and so on. So for the next level, what I have done is I have only transitioned the functions from my system analysis level to the logical architecture level, and I have not refined the function. So whatever function that is available in my system analysis, I have transitioned that into my logical level. So here, these are functions and the containment, again, captured from what was in the previous level. So what we will do now is, we will create a new config file from scratch to query this part of the model. And we also want to create a view that the user can use to refine or break down the function we already have in the logical level. So again, like I mentioned, I have the plugin installed. So to install the plugin in your Capella, we will just go to help, install new software, and to the editor. So I'm going to create a new file, and let me call this as logical functions L3.mse. So the .mse is how the editor will know that we are trying to create a configuration file for MapleMBSE. So once I create again the new file, we will start editing the file. If you remember from the slides, the first part that we want to include is the E-code import. The best way to do this is like, if you have MapleMBSE, you'll have the examples folder in which you'll find Capella examples. Reuse the queries, because for most of the queries that you want to work with, you will have an example and you can reuse what is available already. So for the E-code import, I have the Capella sample. Again, this is available with your installation. I'm just going to copy the part for the import E-code. So this kind of tells MapleMBSE that we are going to work with the Capella model, or also the editor that we are going to create the queries based on the E-code that we are importing here. Again, you can notice that these are kind of like an hyperlink, but we did not make any connection to the hyperlink. We did not connect to any website. There's more of an alias kind of saying that MapleMBSE, that these are the equal that we work with, and the tool or the modeling tool this belongs to is Capella. So there is no connection or exchange that is being done to the link that you're going to see here. So once I define the echo, we want to now define the data source. So what data source is? Data source nothing but it is a pointer to the part of the model that we want to work with. As I mentioned to you, we are interested in navigating to the logical function and working with the function that is being in the root logical function. So the data source query that we are going to create is going to navigate again from the root project. We want to go into the model roots, or wherever the different architecture levels are being owned. And then we navigate to the logical architecture. From the logical architecture, we go to the functions package. From the function package, we navigate to the root level function and then all the sub functions. So this is the navigation that we are going to do for the data source. So you can see MapleMBSE will give you automatic syntax highlighting and suggestions. All you have to do when you're in the editor interfaces, you have to click control space. Control space will give me automatically the queries that's possible. So let's say for data source root project. So this is kind of reserved keyword. Any Capella project that you're going to use, the first data source that you will start from is root project. So when you use control space, it's going to give you the queries that you can use. And let's say I want to query the architecture, like to give me a list of all the architecture. So from the root, I'm going to go to owned model roots. Again, this is in the system engineering level. So this is how Capella is defined, or the Capella eco is being defined. So from there, we go to the architecture. So our interest is actually the logical architecture. So instead of, let's say, going to the system analysis level or to the physical level, I'm going to add the classifier for logical architecture. So this says MapleMBSE that you will find different architectures within the system engineering route, but of all those architecture that you find, what we are interested or what should be navigated to is the logical architecture. So from the logical architecture, let's navigate to the functions package. So what I'm trying to create here is a chain data source. Instead of breaking down or creating a chain of data source, I could also continue with the same data source. As you can see, we could do it. The main advantage of this is now I could create different data source from the logical architecture. So instead of functions package, maybe I could query from this architecture data source to, let's say, to the logical component and so on. So here within the architectures, there will be one functions package, and the functions package is called logical functions package. And this logical functions package has a name, which is logical function. So this name, logical functions, this comes from this package we see here. So in this specific query, like in the logical functions package query, within the logical architecture level, we are querying the function package, which is called the logical function package. Again, if I click on this and if you view it in the semantic browser, you can see that this specific package called as logical functions, it's nothing but a logical functions package. And that's what the classifier that we're using. And the name for this functions package is logical function. Now again, I'm going to break the query down. Within the logical functions, I'm going to navigate to the root logical function. So again, if you remember, you will be able to find similar queries in the example that is already available in Capella. So instead of navigating through every query, what I'm going to do is I'm just going to copy the queries that's available in the example. So here we can see that I already have queries defined for the logical functions, and I'm just going to copy this query and add it to the file that we are working with. So the error is because of change in name. So here you can now see the error, and MapleMBSE will also give you the possible suggestions that you can use to rectify the error. So the error here is like MapleMBSE is not able to find the logical function package because here I have defined the data source as functions, but here it is just a function. So if I just replace this information here, now it's able to find or it's able to find the chain data source and the error is being resolved. So we have defined the data source up to the logical function level. So we have navigated to the list of all the logical function inside the root logical function. So now it's time for us to define the sync table schema. So here I'm going to say the sync table schema, logical functions schema. This is the user-defined name. I'm going to say what dimension and the logical function. So you can see error that's saying that we need at least one key column that is being defined, because we have not defined, okay, for the logical function, what information we want to display to the user. So let's say we are interested only in showing the name of the logical function. So I'm going to say user column to display the name, and I'm going to call this as level 1 logical function. Okay, so this will get me the name of function in this level. So we'll be able to see a list of all the functional names here. But as we discussed earlier, we want to do 3 levels of logical function. So we want to get level 3 logical function. If you use a double forward slash, this will be considered as a comment, and anything that's on this line will be ignored. So we want to get up to 3 levels of logical function. So here I'm going to again use record dimension. So dimension is kind of how we say we want to navigate into your Capella model. So the first dimension is whatever is in our logical function. So this is our first dimension. So when we go on to the next dimension, for the logical functions at level 1, it will get me details on the level 2 level. If we go on to level 3, it will be another sublevel for the display data and so on. So again, you can create any arbitrary number of levels that's required for your project. But to keep it simple, we will go only up to level 3 for this demo. So again, for the record dimension, in this layer, we need to provide the navigation. So on the first level, what we did is like we have already done the navigation for the logical function. So when we are inside the logical function, we also need to tell in the queries how to navigate from the logical function to the next level. So the way the navigation works to the next level is there will be some own logical function. Own functions, and this will be logical function. So this is how we navigate to the next level. Again, I'm going to say key column name as say level 2 function. Now, similarly, we'll add another query. And I'm using control space to bring in all the suggestions on function. And this is also going to be a logical function. And we are again going to query the column slash name as level 3 logical function. So now we have created a schema that will get us information for 3 levels of logical function and will display the name for us in the Excel interface. So you can notice that we have defined the schema, we have defined the data source, but we have actually not linked the sync table schema to the data source or like to the part of the model from which I'm going to get this information. So what I will do is I'll just use an alias for a sync table. I'm going to say create a sync table. Let's call this as logical functions table. And this logical functions table will get information from the logical functions data source. So basically what we are mentioning here is we are trying to link the schema with the data source that the schema will get the information from. So for example, let's say you create a logical function for one of the sub-functions. Instead of say stopping our query at the root logical function and level 1, you're interested to expose only a certain logical function to a system engineer or a subsystem engineer, because the other functions or other levels of function are not relevant to them. So in that case, I can create a schema that is common across different functions. But just by adjusting the data source, I could say, let's say, for example, a function for a propulsion system or function for a power system, we can, just by changing the data source and making the schema same, we'll be able to create different tables. So that's what we are kind of doing here. So I'm just linking our schema to the data source, which is going to get information for it. Now we are going to define the worksheet template. So the worksheet template and the workbook, as I mentioned, this is what will tell MapleMBSE how the view has to be in your Excel. Right. Okay. Template. Let's call this as logical functions level 3. And I'm going to bring in the logical function schema for this. So I also need to mention like for which schema I'm creating the worksheet template for, because I could have different schemas in the same config file. Like I could bring in information of the logical function or the system function or the logical component. And in the worksheet template, you will say, okay, this template actually I'm creating for the logical function schema or the logical component schema and so on. Here for the logical function schema, I'll say which view we want to show in the Excel interface. I want to use a vertical table view and some user-defined name. So this is the name or the name range in which the table will be displayed in Excel. And I'm going to say start from row 4, 5. I'm going to define the different levels. So key field, again, key field for level 2 function, key field for level 3 function. So I'm using key field here because like we have defined each name as a key column. So since we have used key for the columns, we will use key in the fields when we are defining the template also. So the column and the fields, they are nothing but in the Excel view, you will be using one column to display one type of information. So the field and column, they are just interchangeable with the schema. This is just to mention that there's the key field name is for level 1, level 2, or level 3. So once we define the worksheet template, I'm going to say to create a workbook, because without a workbook, you can launch MapleMBSE, but if you are not mentioned the workbook, it will just be an empty Excel sheet that does not display any information. So I'm going to say add a workbook, and the worksheets that we want to display is logical functions L3. And this logical functions template gets information from the schema logical functions template. Again, this is because we have defined the worksheet template based on the schema. So I have defined the logical functions L3 template for the schema here. And in the worksheet, I'm going to say like the template will get information from the table that we added here, like the sync table, which is basically saying the schema gets information from this data source. And for the worksheet, we just give the combined information. Again, for this simple view, we have only one schema and one table. But when you're using multiple schemas and multiple tables to be displayed in the same worksheet, you'll see that why we want to kind of pass how the sync table schema gets information from the data source, or why we use the alias within the worksheet template and so on. So we have now completed the config file to query a Capella model. Like again, it could query any Capella model because the containment or the structure of the Capella model is the same. So this is going to be the same logical function package or the root logical function with logical function as its own function. Any Capella model that we want to query will get us information that works bidirectionally now. So I'm going to save this file and let's launch this configuration file to see the information that we want to get from the fitness tracker model. So we created logical functions L3. I'm just navigating to the location of the file. To launch MapleMBSE, all you have to do is you have to double click on the config file. So this config file or the file with .msc extension. So this is what we call as a configuration file with all the queries that we created now. So once I launch MapleMBSE, it will automatically pop up in Excel. So it has brought the Excel into my other worksheet. And it will ask me to select the Capella model that we want to open. So you can see that it's asking me to select the model file. So I'm going to navigate to where my model is, fitness tracker, and I'm going to directly select the Capella model file or the .capella file. So once I click open, MapleMBSE will bring that information into the Excel interface. Again, like you do not see any headers because we have not created a template. We have only created a config file. So here, if we make a comparison to the functions that's available, you can see these are the list of functions, the sub-functions, and so on. We do not see any information at level 3. That is because all the functions are just 2 levels, like you have a top level function, a sub-function, and so on. Let's say now I want to define a level 3 sub-function. Let's say for the track heart rate function. So for the track heart rate sub-function, I want to include, let's say, 2 new sub-functions for level 3. And in the model, we can see that for the track activity, we have the track heart rate, and the track heart rate, it does not have any sub-function that's being defined. So from MapleMBSE, what we will do is we are going to refine this track heart rate example. The track heart rate function further. So I'm just going to use Excel copy paste. And you see an error because this information already exists in the model. So that's why MapleMBSE is flagging this row as a duplicate, because the track and monitor daily activity and the track heart rate, they already exist in the model. So let's say to track a heart rate, I need get activity data. So for example, I need to get the activity data if the user is, let's say he's in a workout session or if he's sleeping and so on. So I'll need to get the activity detail to track the heart rate. Activity detail. So this, you can see the information is now accepted and the error is being removed. And let's say in addition to this get activity details, I want to say monitor or let's say send pulse, receive pulse signal. So I mean all this are sub functions to track heart rate. And I'm just going to use the Excel drag and drop to fill that information. So now you can see that we have added 3 sub functions for the track heart rate. To see these changes in my Capella model, all you have to do is click on the save button. I'm going to click the save. The information is now saved to the Capella model, and I'm going to just refresh. This will get us the level 3 for track heart rate. So you can see that the functions now are being automatically populated and captured as the Capella elements itself. And if I open the logical functions package, we will be able to see track heart rate and its a function. Here, simple receive signal and get activity detail. So you can see that the diagrams are also automatically updated along with the functional breakdown. The workflow, again, if the user makes or modifies some change in Capella, we'll be able to see the change back in MapleMBSE also. For example, let's say I just want to rename send pulse to send pulse signal, and I'm going to save this information. In MapleMBSE, all I have to do is I'm going to update my model information, and it's going to complete the update and get a warning saying that the model is being reloaded, and clicking on OK is going to give me the latest update. So you can see that the send pulse has now been renamed as send pulse signal. So you can see how a user interacting with the Excel interface, they don't need to actually know which part of the model the logical functions are, or what a logical function is, how they have to create the containment, or how they have to do the system breakdown, and so on. For them, they'll just work with the simple interface that we see here, like they see level 1, level 2, level 3 subfunction. They can just work like they're working or updating an Excel table without understanding the complexity of the modeling tool or the modeling language. And once they make the edits or review or change and save it back to your Capella model, the information gets stored as Capella model elements itself as logical function, or it updates the uh, logical functions breakdown diagram and so on. So this is what you can achieve actually using MapleMBSE. You don't need a user to actually run Capella or have Capella in the environment to use MapleMBSE. You create the configuration file, like the configuration file is being created by a system engineer who knows Capella, who understands the Capella modeling language, and so on. And they send the config file to the other stakeholders who are not familiar with the modeling environment. So this stakeholders or the subject matter experts, they will just launch the config file, they connect to the Capella model to which they have to contribute. They see the information as Excel tables or matrices. They add their input, they review, or let's say they add some comments and save it back to the model. This information is being captured, structured as Capella elements itself. So we actually saw how to create a simple config file. This is how you kind of build on to create views for safety analysis, or like to query the components, or if you want to break down the logical components or physical components and so on. And we are at the end of today's webinar. So as a summary or as a quick recap, we initially discussed like what MapleMBSE is, how it can bring in subject matter experts to contribute to a system model by capturing their knowledge or reviewing the information that is already captured in the Capella model and so on. So MapleMBSE uses a tree-based model transformation that brings in Capella elements and displays the information as a table view. So it is not actually doing an export or an import. It is always connected to the Capella eco. So if the user makes a mistake or if they try to do something, they will see a warning that's saying like the information they have entered is not valid and so on. And we also saw how we can use MapleMBSE editor to configure a simple functional decomposition template. Similarly, you can build on different queries to get other information from a Capella model. Find traceability. You can also create queries to basically kind of like say to test your model quality, as you can query what are the different requirements in your whole project, and you can find information of, okay, these are the requirements that has certain tag value, or there is the requirement that has not been linked without any ongoing, or sorry, without any outgoing or incoming relation to different model element and so on. So basically, any kind of queries you can create with MapleMBSE, and there is also queries that you create to make it a bidirectional connection, as we saw in today's demo. So